Okay, so welcome again to the college. For those of you who just joined us, my name is Vincent LaBella, and this is our Nanotext Smartphone Revolution and 2012 Nanotext Competition. I'm going to give a little presentation on the history of the telephone, all the way from the first telephone call up to today's modern cell phones, and give you a little insight into what we do here and how it's impacted the evolution of the smartphone. And at the end of that, then we'll have a competition for the fastest texting. We'll have a bunch of rules for that, and so get your cell phones warmed up. This will be the first talk I'll tell you to turn your cell phones up. You don't have to turn them down. If they ring or they vibrate, that's great. That's what we want. I have one in my pocket. I turn the volume all the way up, so if someone calls me, we'll have some fun with that. Okay. So great. Should I get the door? Let me get the door here. So Steve, Steve's going to be advancing the slide, so let's go to the next slide. So from talking to texting, brief history of the telephone and the technology behind its evolution. You know, it wasn't too long ago, I remember growing up, I had one telephone in my house. It was bright yellow and hung on the wall in the kitchen. Right? And what that meant was that every phone call that, okay, see, I'm getting, I have no idea who that is, but I'll ignore that. It wasn't too long ago where almost every conversation you had to be at a place, right? You called a place, but nowadays we call people, and that's because of the cell phones. And just the recent evolution in smartphones has really just been in, let's say, the past 5 years. And a lot of that has to do with our ability with something called nanotechnology and our ability to make transistors very, very small. But as you'll see in the talk, the transistor, when it was invented, wasn't invented to make computer chips with. Okay, so let's go to the next slide. So basically, telephones are about communication, right? We're social creatures. We need to talk to one another. Communication is not just about learning and growing. It's a survival instinct, right? If there's a big rock coming and you see it rolling down a hill and your friend's in the way, you could yell, say, hey, get out of the way, right? Or some big crazy monster is going to eat your friend, you can tell them to get out of the way. And so it's easy to communicate with someone if you're in the same room or you can hear each other. If we're not next to each other, let's go to the next slide. Of course, we have to hear. If we're not next to each other, if you go back 150 years ago, you had a couple options, right? One was yelling really loud, or, of course, tying a string between two cans, right? And that was it. That was how we heard each other. But then something happened. Let's go to the next slide. Late 1870s, the telephone was invented by Alexander Graham Bell. I'm sure most people are aware of that name, familiar with that name. Actually, Alexander Graham Bell was actually an audiologist, which is something that he was studying, helping people to hear. And so what he really invented was the microphone, the part of the telephone that actually takes the voice and translates it into electrical signal that can be amplified. He invented the microphone, and then he wanted to amplify the sound so people could hear. People who are hard of hearing could then hear the word better. He thought that if I could just make someone's speech louder, then these people could hear. And so he invented the microphone, which was then, of course, turned into a telephone by stringing lines down it. Okay, so let's go to the next slide. Of course, the benefits of the telephone are is that we could then communicate over long distance. Right? The world just gets smaller. Right? We can talk to someone anywhere on the world without them being right next to us. And that's a great thing. Right? That was a new thing. We've never been able to do that. That's just really fantastic. But of course, it creates a problem. Let's go to the next slide. The problem is everyone wants a phone. Right? And so if everyone has a phone, how do you connect everyone's phone to everyone else's phone? Right? And so if you have maybe just 5 phones in the world, it's pretty easy. You just would have some type of switch that would connect the wires to the different phones. Right? And then if I want to talk to this guy, I just connect to that switch, or that switch, or that switch, or that switch. Right? But of course, if you have 5 people, it's easy. But if you get 5,000 or 50,000 or 500,000, let's go to the next thing. The solution was a switchboard. Right? And there were these big switchboards in most cities where mainly women operators would connect wires from someone's phone to another phone. They call up and say, connect me to so-and-so, and they would connect it. Right? And this worked, right? The problem is that as the number, the fastest any human can kind of switch is about a second, right? If you think about it, I could maybe connect this wire up in about a second. The problem becomes, as more and more people get telephones, right, to keep the connection times down to where they're, let's say, under, let's say, 10 seconds, like if you call an operator and say, you know, you don't want to wait that long, you have to start employing as many people to switch the phones as there are people with phones, and this just becomes an impossibility. So let's go to the next slide. So what they came up with were mechanical relays. So these were very simple switching devices that could work electronically, and they worked about 1,000 times faster than a human. So about 1 millisecond they could switch in. This is just a simple electromagnet. You energize the magnet, closes the switch, and they had these switching boards set up, and they're kind of loud. They make a lot of clicking noises, and so the telephone switching rooms would be sort of loud clicking and buzzing noises. Sometimes they get stuck, but nevertheless it was a great advancement. Okay, let's go to the next slide. Another type of device that was around at the time that could switch was a vacuum tube. And some of you may remember vacuum tubes, and you could use vacuum tubes for a lot of other things besides switching, but they were invented in 1907. People tried to use them in switching, telephone switching things in the 50s and 60s. They were about 1,000 times faster than a mechanical relay. But there were some problems with them. Some of the signals that they had to use, they weren't quite compatible with the relay, but nevertheless they tried to use them, and they used them successfully, but they weren't really compatible with the equipment, but they were ultimately faster. So then, let's go to the next slide. In 1947, three engineers at Bell Labs invented the first transistor. Right? And the transistor is a switch. Okay? It's nothing more than a simple switch, but it's made out of parts that don't move. It's just made out of solid materials, right, that you wedge together. They just wedged a piece of, I believe this is germanium, into gold, and that created a transistor. Why that is, well, I could give you a whole lecture on that, but let's not spare the details. But that is something that can switch, and there's no moving parts. It's all solid material, so we called that sort of solid state electronics, right? And it switched about 1,000 times faster than a vacuum tube. So right there, it's 10 to the 9, a million times faster than a human. About every nanosecond, even faster today, you can switch a transistor. And that was developed for the phone system. And the first switching systems for phones were utilized in '65. So in '47, from the lab to the first kind of switching stations in Jersey, I believe were installed in 1965. Okay, let's go to the next slide. So then, someone had a crazy idea. When they invented the transistor, they weren't really thinking about this, but someone said, hey, you know, I can take transistors, and if I can shrink them down and put them on a tiny piece of silicon, then I can create a computer chip. Right? And the first computer chip ever made with 10,000 transistors on it was the Intel 4004. It came out in 1971. It was the first computer processing unit. And this was the first chip that very similar to today's chips that you find in your modern cell phones and computers, except just a lot smaller and a lot less powerful. And so once that happened, right, then a race was on. Let's go to the next slide. A race was on to make those transistors small. Small, 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 small. The first transistors made on silicon were about 10,000 nanometers. That's 10 microns. It's about 1/100th of a millimeter. Just a fraction of a thickness of a penny, you can imagine. And they just had about 1,000 or so transistors on them. And over the years, we've slowly shrunk the transistors down. Okay, Steve, hit the next animation there. Until about the year 2000. When we got after 2000, we were starting to make transistors below 100 nanometers. Right, a nanometer, 1 nanometer is a billionth of a meter. And a nanometer is about the size, the distance between atoms in materials. And today, we've slowly started to make transistors almost down to about 20 nanometers today with 1 billion, billion with a B, 1 billion transistors on a computer chip that are all 22 nanometers in size. Right? That's quite remarkable, right? What we do here at the college is we work out here. So we do research in this area, this sort of unknown area. Because eventually we're going to hit a limit, right? Eventually we can't make transistors smaller than an atom, right? And so there'll be a huge limit, and if we can't make transistors smaller, well then we can't make them faster and we can't put more of them on a chip, so it's going to kind of be a slowdown in our sort of technological evolution, but we're doing research on that here today. So let's go to the next slide. So if you just look at the first cell phones, or the first, I'm sorry, telephones, and you look at just the evolution, there's a nice display out. The New York State Museum has brought along a display of old telephones. So the first telephones are really nothing more than almost somewhat electromechanical devices, right? A speaker, a microphone. Even the first cell phones were really huge, right? They were big things. You had to carry them around. And it wasn't, this is what we call before the nano era. And just recently, it wasn't really that long ago, the year 2000, we started to get phones that were smaller. Let's go to the next. Keep going, flip phone. My first phone I bought, I think it was 2003. And it was a flip phone. And now, as we enter the nano era, right, this is iPhone 2007, not that long ago, the phone has really turned into a computer in some sense. And talking on the phone, I mean, who talks on phones anymore, right? We all text on them, right? And what texting does, and one of the benefits of texting, is that not only does it shorten the space between people, but it lets us communicate over different time scales, if you will, right? I can send you a text message, and if you're busy, right, you can wait to respond to me, right? You don't have to be there. It's not immediate, so you can respond whenever you want. Of course, unless you're trying to drive and text at the same time, you shouldn't be. But nevertheless, texting kind of adds sort of another dimension, another kind of more efficient way to communicate. And any engineer will tell you that if you can make a system where sort of the senders of information, let's say the two people communicating over that system, don't have to respond to each other immediately, that is, can send and receive things in different times, that system will be much more efficient. And that's one of the great things I think about texting. And so today, these modern telephones are really computers, and they're made powerful by the tiny pieces of silicon chips in there with 1 billion transistors on them, all at 22 nanometers, right? The smaller we can make transistors, the faster they operate, the more features we can put on a chip. And so I just can imagine what the next iteration of smartphones are. You know, someone made this comment to me. It used to be that cell phones kept getting smaller and smaller and smaller and smaller, but now they keep getting bigger and bigger and bigger and bigger, right? We want these big screens, right, to have bigger phones. The next iPhone 5 is bigger, right, than the old iPhone. If someone said, oh, I got this new cell phone, you went back 10 years ago and say, hey, I got this new cell phone coming out, and guess what? It's going to be bigger than the one you have right now. People will be like, why do you want to make a phone bigger? You should make it smaller. But today it's kind of changed, right? Because we interact with phones a lot differently. So that's the talk. I hope I've given you some information.